Sn is equals to n by 2. This 2a can be written as a plus n minus 1 times d. And this is nothing but the last term, or we can say the nth term. So we can write it as n by 2 a plus l also. Right, Lena? This was
Yes.
also one of the formula. Are you able to recall all these formulas?
Yes, ma'am.
Let's start with the questions. Okay, few questions we will be doing from arithmetic sequence, arithmetic progression, so that you will be able to see like these question will be quite, the level will be higher than the class 10 question, or I'm saying similar question you have done in class 10 also. So I'm taking few questions from arithmetic sequence. This also you need to understand at first while doing sequence and series, then only we will be moving ahead with the geometric progression. Since this concept is known to you, the formulas and everything is already known to you, let's start with the question. Okay, so let me take a few questions from arithmetic progression. Just a second. Let me take it out the question. Okay, so the first question is, if 9 times the ninth term of an AP is equals to 13 times the 13th term, then the 22nd term of the AP is, let's say options are there, option A says 0, option B is there, that is 22, option C is there, that is 198, and option D is there, that is 220. Let's solve it. This is like this type of question you have already solved in class 10 only. Okay, so let's see what exactly the question says. If 9 times of what? The ninth term. What will be the formula? Like, how can we write ninth term? A9 if I have to write, what will be that? Or maybe T9 if I have to write the ninth term, what will be that, Lena? If let's say the AP is having a first, yeah, tell me.
A plus 9 minus 1 times D.
80. Can I write?
Yes, ma'am.
And the 13th term also we have to write. What will be 13th term? Let's write it quickly.
A plus 12D.
A plus 12D. Now according to the question, according to question, 9 times ninth term is equals to 13 times 13th term. This is what we can write, right, Lena? Let's see
Yes,
what
ma'am.
equation we are getting from here? So 9a plus 8 9 times 72d is equals to 13a plus 12 3 times 36, 6 carry 3, 12 1 times 12, 13 14 15, 156d. Okay. Now what we'll be having, if we will be keeping all the a on one side and d on one side only, so we will be getting 13 minus 9. What's 13 minus 9 is what?
4.
4a. And 156 minus 72 is what?
84.
uh it's what you said, 84.
Yes, ma'am.
uh yeah, it's 84. So plus 84d is equals to 0. That means if we will take out 4 common out, it will be a plus 4 2 times a, 4 1 times 4, 21d is equals to 0. Right, Lena? This is what we have got the equation according to the given question, right?
Yes, ma'am.
Now what exactly is asked in the question? Let's read it carefully. Then the 22nd term of the AP will be, what will be 22nd term according to the formula? A plus,
21D.
have we found a plus 21d?
Yes,
What
ma'am.
is the value of that?
0.
So can I mark 0 over here?
Yes, ma'am.
So this was very simple, right?
Yes, ma'am.
Let's move ahead. Like this only we will be solving few questions from AP, and then we will be moving to then we will be seeing few extra thing, that is properties related to AP, and then we will be moving ahead. Okay, let's see what are the next question. So the next question is, find the number of terms in the sequence 4, 12, 20, 108. Option A is 12, option B is 13, option C is 14, and option D is 15. Can you tell me how can we proceed from here? Number of terms. If
We
our
have to
A,
use the formula.
yeah, which formula?
AN is equals to A plus N minus 1D.
N is equals to A plus and minus 1 into D. What is AN? What is A? What is N?
Uh,
D?
108 is equals to 4.
What is N? We have to
8.
find N, right? Right, Lina?
Yes, ma'am.
And common differences?
8.
8. Let's solve it quickly. So 108. Here we are having, if 4 we will be substituting, like shifting to other side, it will be 108 minus 4 is equals to 8 times and minus 1. Let's do the solution simplification. So 104 is equals to 8 and minus 1. 8 will go over there and will divide 104. So let's see what exactly are we getting. So will it divide completely? 8 1 times 8, 8 3 times 24. Is it clear? So n is equals to 13 plus 1, that is 14, right?
Yes, ma'am.
The number of terms are 14. Okay, let's move ahead. Now the number of numbers lying between 100 and 500 that are divisible by 7 but not 21 are, or you can say is how many numbers are there. Option A 57, option B 19, option C 38, and option D none of these. Okay, let's understand the question at first. What exactly the question says? The number of numbers, like number of terms, okay, lying between 100 and 500, in between 100 to 500, that are divisible by 7 but not divisible by 21. So first thing first, can you tell me what can we do at first over here? Any idea? Let's see how many numbers are there in between 100 to 500 that are divisible by 7. First thing. Then we will think about the numbers which are not divisible by 21 and all. First thing first, let's see how many numbers are there, just like the previous question, which are divisible by 7 in between 100 to 500. How can we do so? So we can divide 100 by 7 and we can check it. What will be the next number which will be divisible by 7 completely? So here we can see 7 1 times 7, 3, 7, 7th, 4 times 28. Okay, remainder is 2. So 14 into 7, this is the first number. Before, let's multiply. 14 into 7 is what? 14 into 7 is what, Lena?
98.
So before 100, there is a number 98 just before 100, the last number before 100. That is 98 and it is divisible by 7 completely. But we need numbers after 100. So the next number will be plus 7, right? 105, right?
Yes, ma'am.
Next number will be plus 7. That is 112. Are you getting it?
Yes, ma'am.
The next number will be again plus 7. 119. So let's write it. So our sequence first term is 105. Any doubt over here?
No, ma'am.
Other number, the next number after this will be plus 7, that is 112. Next number will be 119. What will be the last number? So we need to find the number which is divisible by 7 completely before 500. So let's do it same way. Before 500, divide 500 by 7. And whatever we will be getting quotient, we will be multiplying it with 7 to get the number before 500, which is completely divisible by 7. So 7 times 49, then 1, 7, 1 times 7. Let it be whatever remainder we have got. We got 71 times it is fully dividing. 7 1 times 7, 7 7 times 49. 497 is a number before 500 which is completely divisible by 7. Are you getting how we are finding it?
Yes, ma'am.
So let's write it. Our last term also we got in the sequence. Now we have to find the number of terms. Okay. So let's find the number of terms, Lina. Just like the previous question, when the sequence was given and quickly you found the number of terms. So here also let's find how many terms are there. So we will be taking L an is equals to a plus n minus 1 into d. Here we have to find n value. 497 is equals to a is 105 plus n minus 1, and we don't know and we want to find d. Common difference is 7 only, as we can see. Is it clear?
Yes, ma'am.
Tell me what are you getting from here?
57.
Perfect. So in this, in between 100 to 500, there are total 57 numbers are there which are divisible by 7, right? Right, Lina?
Yes, ma'am.
Here only there must be few numbers which will be divisible by 21 also, right? The first number
Yes,
itself,
ma'am.
can you see? It is completely divisible by 21. 21 5 times 105. So we need to exclude such numbers. Okay? From this sequence, we have to exclude such numbers which are divisible by 21. So let's see how many numbers are there which are divisible by 21 now. So the question is now, how can you proceed? How many numbers are there which are divisible by 7 but not 21? So by 7 total, how many numbers? 57 numbers are divisible. Maybe 5 numbers, 10 number, or 15 number, 20 numbers are there in this 57 which are divisible by 21 also, which we need to exclude, right?
Yes, ma'am.
So let's see how many numbers are there in between 100 to 500 which are divisible by 21. Whatever number we will be getting from there, we will be excluding it from 57. Getting it?
Yes, ma'am.
Let's go ahead. So let's make the sequence again. Forget about all the previous scenarios and now. Firstly, what we are trying to do, we are trying to do how many numbers are there in between 100 to 500 which are divisible by 21. Okay. So let's find it quickly. The first term, as you can see, it is 105 only, right?
Yes, ma'am.
Now the next term will be 21 more than that. So it will be 21. 6 to 126. Clear? The next term will be 21 more than this. So 7, 7, 4, 147. Okay. What will be the last term? So the last term, to get the last term, we can divide 500 by 21. Right, Lena?
Yes, ma'am.
So 21 2 times 2, 1 times 2, 42. Remainder is 8. 4 times it 84, 3 times it is 3, 1 times 3, 63. Whatever remainder you are getting, that's completely fine. We have to check how many times it is completely divisible. So 21 into 23. If we will be multiplying 21 with 23, we will be getting 3 2 times 3 1 times 3, 3 2 times 6, 7 8, 483. Okay, you can do double digit multiplication by taking time. So you will be getting 483. Is it clear so far?
Yes, ma'am.
So we got the sequence where the numbers are divisible by 21. Okay, how many terms are there? Let's do it quickly. An is equals to a plus n minus 1 into d. Okay, an is the last term 483. First term 105 plus n minus 1 and d we know it's 21. Can you please tell me what n value you are getting from here?
19.
19. So total 57 terms were there which were divisible by 7. Among that, there were few numbers which were divisible by 21 also. So 19 such numbers are there which are divisible by 21 also. What we have to find? The number divisible by 7 but not 21. That means 57 minus 19. Okay. 8, 3, 38. So there are 38 such numbers which are only divisible by 7. Right, Lena?
Yes, ma'am.
Let's see option. Can you see 38 is there?
Yeah.
This is how we will be solving the questions from AP. These all are, there is no extra concept needed. Whatever concept you have already learned in the previous class, those concepts only we are using over here. Okay. Let's move ahead. If A1, A2, A3, AN are in AP, where AI greater than 0 for all I, then we have to find the sum. 1 by under root A1 plus root A2 plus 1 by root A2 plus root A3 plus 1 by root AN minus 1 plus AN is equals to what? The sum of these all we have to find from here. Options are option A n minus 1. The sum will be this one, or the sum will be this one, or the sum will be this one, or maybe the sum will be none of these from above. Okay, let's understand the concept at first. So here it's given that A1, A2, A3, AN, these are in AP. So if these are in AP, A1, A2, A3, A4, everything, A1, A2, A3, AN are in AP. So can I write A2 minus A1? This is common difference D. A3 minus A2, this is also comes up the same common difference D. Right, Lena? Or maybe A4 minus A3
Yes.
has to be the common difference because this is in AP. Right? Now what we have to find? We have to find the sum of this all.
Yes, ma'am.
Okay. 1 by under root A. We have to find the sum of this. 1 by root A1 plus root A2 plus 1 by root A2 plus root A3 plus 1 by root AN minus 1 plus root AN. This sum we have to find by using the information given, that is A1, A2, A3 are in A. So let's rationalize it. If we will rationalize this one of them, then what we will be getting from here? So if we will rationalize, you already know the concept of rationalization. How we do the rationalization? We just do the multiplication of root A1 minus root A2, right? Right, Lita?
Yes, ma'am.
So we will be having root A1 minus root A2 divided by A1, root A1 is square. That means only A1 minus only A2. Right, Lena?
Yes, ma'am.
Only A1 minus only A2. Can I write this one as minus D? Can I write this denominator as a negative D? Because D means A2 minus A1. I am having A1 minus A2. So can we write A1 minus A2 as a minus D?
Yes, ma'am.
Let's write it. So similarly, our each and every term will get changed. The second term, the third term, the fourth term, each and every term is getting changed just like this one. Now we don't need to rationalize each and every one. Okay, we understood. Okay, this is how we will be getting the term. Now the next term also, when we will be rationalizing, the next term whenever we will be rationalizing it, again we will be getting minus d in the denominator. Can you see it? Two consecutive terms are there, and difference we will be getting, but not in a proper sequence. We will be getting a2 minus a3, that means minus d only, right, Lena?
Yes,
This
ma'am.
green one will also be minus d in the denominator, yes or no? Yes or no? Are you there?
Yes, ma'am.
Okay, so I am going to write our sequence, our summation.
Yes, ma'am.
This got changed to, this got changed to under root a1 minus under root a2 by minus d, plus under root a2 minus under root a3 by minus d, plus just like this one, under root an minus 1 plus under root an, not plus, minus, by minus d. This is how our expression got changed just by doing the rationalization. Is it clear so far?
Yes, ma'am.
Now let's add all of them. So we are taking minus 1 by d as a common, and let's add all of them. So root a1 minus root a2 plus root a2 minus root a3. If we will be writing the next term also, it will be root a3 minus root a4 divided by minus d. If we will be writing one more term, it will be root a4 minus root a5 divided by minus d. This way it will continue. So we will be having plus root a3 minus root a4 plus root a4 minus root a5. Are you observing that every term is getting cancelled over here?
Yes, ma'am.
Plus root an minus 1 minus root an. So if we will be doing it, what we will be getting? A1 is not getting cancelled because no other A1 is there, but A2, A2, A3, A3, A4, A4, A5, A5, A6, A6, every term will get cancelled out with each other. Only what will be remaining? A1 will be remaining and AN will be remaining, because there will be no an before the term an, right? The next term will be an and an plus 1, right, Lena?
Yes, ma'am.
So this is how everything got cancelled, and we are left with only this one, minus 1 by d under root a1 minus under root an. Is there any option like this? Let's check. No. Can you see option number 1, option number 2, option number 3, option number 4? It doesn't look like whatever we
Yes,
have
ma'am.
got. Still we need to work on that. Now if a1, a2, a3, a1, a2, a3, an are in ap, then how can we write the nth term? The nth term will be an is equals to a1 plus n minus 1 into d, right? Right, Lena?
Yes, ma'am.
If we will change the side of this two, if we will keep on one side, why we are doing so? Because I want to make something like this so that we can do the substitution. So an minus a1 is equals to n minus 1 into d. An minus a1 is equals to, by d is equals to n minus 1. Can I write over here? Or a1
Yes, ma'am.
minus an is equals to, if I am taking minus common from here, minus common out, by d is equals to only n minus 1. Is it clear?
Yes, ma'am.
Let's see whether we can do the substitution or not. Okay, here under root a1, under root an is there. So if we will again do the rationalization kind of thing, the way we used to do, just a moment now, let me check. Let me check first, okay? If we will be still again doing the reverse multiplication, so it will be a1 plus an divided by root a1 plus root an. That will give us only a1 minus an in the numerator, and in the denominator root a1 plus root an, and here minus 1 by d is still there. So what we will be having, a1 minus an, this total is equals to n minus 1. So n minus 1, I mean this total, and this total is n minus 1, okay, divided by root a1 plus root an. Let's see any option is like this or not. N minus 1, root a1, root an. Can you see option number A?
Yes, we can.
What we did, what exactly we did, we found from the nth term from a1 a2 a3 as a r in ap, so nth term will be this. From there we got one substitution and we tried to substitute it over here. But when we were going to substitute it, we realized, okay, here we are having root, so how can we do the substitution? Okay, here roots were there, this were in roots, the yellow one. So again, the way we do the rationalization, what we do, rationalization we usually do for the denominator. Here we are doing it for the, like the same process we are doing for the numerator. Okay. So what are we going to do? We will be multiplying with the same thing, like root a1, root an, but with plus sign. Is there any confusion, Lina? Whatever we have done over here.
No, ma'am.
Got it? How we solved it? Let's summarize it. Okay. So the here the question says if a1, a2, a3 are in AP, where ai greater than 0 for all I, it's okay. So we have to find the sum of 1 by root a1, root a2, 1 by root a2, a3. This sum we have to find. So we have written if a1, a2, a3, an are in AP, then the common difference will be a2 minus a1, a3 minus a2, a4 minus a3. That is called common difference, and let's say that is D. Okay. Now we have done the rationalization and we ended up getting this total summation as minus 1 by D in bracket under root a1 minus an, because all the other term just cancelled out each other. Okay. Now, according to the option, we have searched which option will be the correct option. Accordingly, we have done few customization. That's it. Clear?
Yes, ma'am.
Let's move ahead. The number of terms common to 2AP, 3, 7, 11, 407, and 2, 9, 16, 709 is option A 12, option B 13, option C 14, option D 15. So we have to find the number of terms which are common in this AP, in this AP, and in this AP. How many terms are common? So let's write our first AP, that is 3, 7, 11. Can you tell me what will be the next term quickly?
15.
uh, 15. Next.
19,
Next.
23,
Next.
27,
Next.
31,
After that,
35.
let's keep it this much. Okay, I want to show you something. That's why this much numbers I have written. Here 2, 9, 16. Can you tell me the next one? 23. Is it so?
Yes, ma'am.
Then 30. Then
Mm-hmm.
37. Then 44. Then 51. Right? Like that.
Yes, ma'am.
709. So are you noticing few terms are common?
Yes,
And
ma'am.
you will go ahead in the first sequence. You will see a lot of different number which will be common. Okay, so those common terms only we have to find how many terms are common. Okay, if we will be going ahead, it will be 39, 43, 47, 51. So here you can notice one more term common. Can you see?
Yes, ma'am.
That's what we have to find. How many such numbers are there which are common in this AP and that AP? Okay. So how we will be finding that how many such numbers are there which are common in this 2 AP? So what is the common difference for the first AP? It's 4, right? And what is the common difference of the second AP? 7, right?
7.
Now here our sequence of the common terms AP will be 23 first term, 51 second term, and what will be the last term? Last term, whatever will be the last term, that will be smaller than 407. Do you agree with me?
Yes,
It will
ma'am.
be smaller than 407 because after 407, the first AP will not generate any number. So even if the other AP is generating till 709, we will not get anything common. Right, Lena?
Yes, ma'am.
So I am saying whatever be the last term, whatever be the nth term, an, you say, that will be smaller than 407. That short we know, right?
Yes,
Now
ma'am.
the common terms AP is 23, 51. Here the common difference is 53 minus 21 or 51 minus 23. And that is 8, and here 28. So 28 is the common difference. There is one more way of finding the common difference. Okay, that means in such scenario there is a concept that whenever we have to find the common term, we can find the common difference by taking the LCM of these two. LCM of D1 and D2 will give us the common difference. LCM of D1, D2 will give the common difference. And as you can see, we have got 28 only. LCM of 7 and 4 is 28 only, right?
Yes, ma'am.
This is one of the theory which you need to know, that whenever the common term is asking, common difference we can find by taking the common difference of first one and the second, by taking the common difference of the first sequence and the second sequence LCM. Okay, here we have done by our concept only. We can clearly see 51 minus 23 is 28. But you can also find it by this. Now, we know the common difference. We know the first term. And we also know the last term will be smaller than 407. We are saying AN will be smaller than 407. Okay, so here let's apply the formula of AN in arithmetic sequence. A plus n minus 1 into D, that will be smaller than 407. We are making one inequality over here. Inequality chapter you have learnt, no?
Yes, ma'am.
That's what we are going to use over here. That we don't know what will be the last term, but because writing every number over here till 407 is not possible, and writing all the numbers over here till 709 with the common difference of 777 is not possible. So what will be the last term, that we don't know, but that will be smaller than 407. And we also know how to solve the inequality. So let's make one inequality and solve it. First term is, what was our first term? 23. N minus 1, we don't know how many terms are there which are common in both the AP. D, common difference we have got as a 28. Yeah, is smaller than 407. Let's solve it, Lena. We know that inequality we can solve just like an equation. Is smaller than 407 minus 23. That means smaller than 7 minus 3, 4. Here 10 minus 2, 8, 384. Are you getting it? Are you getting it, Lena? How we are solving the inequality?
Yes, ma'am.
Now n minus 1 is smaller than 384 by 28. We don't need to worry about the inequality sign. Once we are just adding, subtracting, multiplying, dividing, everything, whatever operations we are applying, the inequality sign will remain as it is. One thing only, we must be careful that we must not divide with a negative number or multiply with a negative number. If we are doing so, then we need to reverse the inequality sign. So we have not done anything like that. That's why the inequality sign is as it is. Let's divide 384 by 28. 104. How many times it will go? 8, 5 times 40 is 0. Carry 4. 5 to 10, 11, 12, 13, 14. Okay. 4 times 8, 4 times 32, 2. Carry 3. 4, 2 times 8, 9, 10, 11. 112. 8, 3 times 24, 4. Carry 2. 3, 2 times 6, 7, 8. Okay. 3 times it's coming. 84. Remainder is 20. Let's see how many times it will go. 200 we are getting. So we are getting 13 point something. Let's find it till one decimal place at least. So 28, maybe 7 times. 196. So we are getting 13.7. Can you see?
Yes, ma'am.
N minus 1 is a smaller than 13.7. So n is a smaller than 13.7 plus 1. Right, Lena?
Yes, ma'am.
N is smaller than 14.7. Right, Lena?
Yes,
Now,
ma'am.
what is the question? The number of terms. Number of term can't be in decimal number. Okay? Number of term which are common in this AP and that AP. So, we must take the integral value. What is the possible integral value just before this 14.7? Before what
14.
we say? N is smaller than 14.7. So, yeah, is smaller. The possible n value which is smaller than 14.7 is integer. What can be that?
14.
14. So number of term can't be 14.7. That's why we are taking the best possible value of n. Is there any option? 14. Yeah, this is the correct option. Got it?
Yes, ma'am.
Let's move ahead. Now few important results are there. Till now whatever we have discussed, that was completely based on the formula of arithmetic progression. Now here we will be seeing few important result, or you can say the properties, which says that These are not properties, these are few important results. Just after this one we will be discussing the properties. So the important result, the first one says that sum of first n natural number will be, for sum of first n natural number, there is a formula for that. Okay, that is n into n plus 1 by 2. How we are getting this formula? N natural number means 1, 2, 3, 4. These are the natural number. The counting number starts from 1. Those are natural number, right, Lena?
Yes, ma'am.
This is in AP. Can you see? Where the first term is
Yes,
1,
ma'am.
the common difference is 1. So n natural number sum, what is the formula of sum of n natural number? Like sum of n terms of AP, what is the formula? N by 2 in bracket. Can you tell me?
2a to n
N
minus
minus,
1d.
let's substitute the values. N by 2. A is 1. So 2 plus n minus 1. D is 1. So we will be having n by 2. 2 plus n minus 1. That means n by 2, n minus 1, n plus 1. So n into n plus 1 by 2, and that's what the formula says, n into n plus 1 by 2. Can you see?
Yes, ma'am.
So the formula of sum of n natural number from now you are going to use directly as n into n plus 1 by 2. Okay, in future also when you will be in class 12 or when you will be in higher classes, then also you are going to use this formula, but you must know it came from this arithmetic progression concept only. Okay, now the next formula is sum of an odd natural numbers, sum of an odd natural number, that means 1, 3, 5, 7. The sum, there is a formula. So let me write the formula first. The formula is n square. How we are getting? So let's do it quickly. So here a is 1. The common difference, what is the common difference, Lena?
2.
2. So sum of n term will be a plus n minus 1 into d, right? Right, Lena?
Yes,
Sorry, sum of n term will be n by 2, 2a plus n minus 1 into d, because this is not nth term, we are finding the sum. So let's substitute it quickly. N by 2, 2a, that means 2, plus n minus 1, and d is 2. Okay, let's see what we are getting after doing the simplification. N by 2, 2 plus 2n minus 2. 2 to go, gone, and we ended up getting n by 2 into 2n. Can you see we are getting n square?
yes, ma'am.
So memorize this formula, that sum of n natural number formula is n into n plus 1 by 2. Sum of n odd number, odd natural number will be n square. Okay. Now the next formula says similarly we can find the sum of n natural even numbers also. Before that there is an important result, one more, that says that Tn is equals to Sn minus Sn minus 1. Okay, this is the third important result. What exactly it means? So it means that nth term, yeah, it means the nth term, that is Tn, is equals to sum of n terms Like let's write it. The sum of n term, that means t1, t2, t3, t3, or you can write a1, a2, a3, an. Sum of n term, and Sn minus 1 means sum of n minus 1 term. So t1, t2, t3 plus tn minus 1. Right, Lena?
Yes, ma'am.
And if we will subtract it, can you see all the term will cancel out each other? Can you see?
Yes, ma'am.
And we will end up having tn. So this result came from here only, just by subtracting the sum of n term and the sum of n minus 1 term. Obviously, if we are having 5 terms and if we will subtract the sum of 4 terms, so we will end up having the last term only, right?
Yes, ma'am.
So this is one of the result. How we are going to use it? Let's see. So here the question is, if the sum of n terms of an AP is given by Sn 3n plus 2n square, then the common difference of the AP is, we have to find the common difference. Option A 3, option B 2, option C 6, and option D 4. Okay. So here the sum of n term is given. Okay. So let's write what will be the sum of n term is 3n plus 2n square. That this is already given in the question itself. Now here, if we will be taking the sum of first two term, that is t1 plus t2, what will be getting from here? The sum of first two term. So 3 times 2, right? Plus 2, 2 square, right, Lena?
Yes, ma'am.
Is equals to 6 plus 4, 2 times 8, 14, right?
Yes.
Now the sum of one term, if we will be taking, that means only the first term, t1, that will be, we will be substituting 1 over here. So we will be getting 3 into 1 plus 2, 1 square. That means 3 plus 2, that means 5, right? And if we will be subtracting both of them, then we can see t1 will cancel out each other. And if we will be subtracting the result also, this also, then we will be having, can I say, t2 we got as a 14 minus 5, that is 9, right?
Yes, ma'am.
T2 we got 9. What we have to find? We have to find the common difference. And T1, can you see? T1, only T1 is 5.
Yeah.
So if T2 is 9, T1 is 5, what is the common difference? What is the common difference, Lena? T2 means term 2, T1 means term 1.
Um,
What is the
9
common
minus
difference?
5.
9 minus 5, that is
4.
4. Let's see, any option 4 is there. Yeah. Can we say this option is the correct option?
Yes, ma'am.
Let's summarize this one. Sn we were having, and then we needed to find the common difference. We don't have to go ahead so far. Only T1, T2. Let's take two terms. Let's take one term sum. The sum of first two term and the sum of one term. That means only the one term, the first term. Let's write it. Let's do few simplification and let's find the common difference. Clear?
Yes, ma'am.
Let's move ahead. So this is how we are using this concept. Okay, Sn minus 1 is giving us Tn. So this concept, without directly jumping with the formula. We are doing the process. We are understanding the process and we are doing it. Okay. Now the properties of AP. The first property of AP says the common difference. Have you seen? It can be zero. It can be a negative number. It can be a positive number. Right, Lena?
Yes, ma'am.
So here the first property itself says the common difference can be zero. It can be positive or negative, which you already know. You have already seen such sequences where the common difference is negative. You have seen the sequence where the common difference is zero. Like even if I am writing the sequence 1, 1, 1, 1, 1, still we can say it's in AP because all the common differences are same, right?
Yes, ma'am.
So the common difference can be zero, can be positive, can be negative. Doesn't matter. Only thing which matter is every like the gap between every two consecutive term has to be same. Then only we can declare it's an AP. The gap is positive number, it's a negative number, it's a zero, doesn't matter at all. Okay, this is what the first property says. The next property says if A, B, C are in AP, then 2B is equals to A plus C. Have you seen this? Do
Yes,
you
ma'am.
know? Yes, you know this. From where we got this one? We got it from B minus A. The common difference is equals to C minus B. The other common difference, like the gap between these two is equals to gap between these two. When we will compare it, we will end up having 2B is equals to A plus C. And that's what I have written it over. So this is also one of the property. Whenever we have, like sometime we need to use this property where to generate the relation between A, B and C to get one equation, or you can say. Okay. So here only let's see how we will be using it. The question says if logarithm of 2 base 3 log 2 to the power x minus 5 base 3 and log 2 to the power x minus 7 by 2 base 3 are in AP. Determine x. So now only can you see this property A, B, C are in AP, then we can write it like this. Right,
Yes,
Lina?
ma'am.
So here also A, B, C are in AP. So we can write 2B is equals to A plus C. Yes or no? Let's write it.
Yes,
Let's write 2. Our B is the middle term. A plus C. Is it clear?
yes, ma'am.
Now log m plus log n can be written as log m into n. Can we? Do you know?
Yes, ma'am.
Log m times n is equals to log m plus log n. Do you know this relation?
Yes, ma'am.
Okay. So let's write it. Let's multiply them because both are in addition. So 2 times 2 to the power x minus 7 by 2. Here we are having this. This we can write it as a power. Right, Lena? This we can write it as a power. Yes or no?
Yes, ma'am.
Let's write it. Basically, first thing first, I want to remove logarithm from both the sides. Okay. So since bases are same, everything is same, we can remove it. Now we can remove it from both the side, and we can say 2 to the power x minus 5 to the power whole square is equals to 2 times 2 to the power x minus 7 by 2. Any confusion over here?
No, ma'am.
Let's move ahead. We just need to solve this equation now. Now solving this equation, it may look like how we will go ahead and how we will be solving this one. But let's start solving. A minus b whole square. A square minus 2ab plus b square is equals to, let's multiply them. Whenever we do the multiplication here, 2 to the power 1 is there. 2 to the power 1 into 2 to the power x will be 2 to the power x plus 1, right?
Yes, ma'am.
Here 2 and 2 will cancel out each other, so minus 7 only. Let's see what exactly are we getting over here. So 2 to the power 2x minus 10 into 2 to the power x plus 25. This minus 7 I am just pulling it to this side, plus 7, and this 2 to the power x plus 1 also I am taking it this side. So minus 2 to the power x plus 1 is equals to 0. Let's see what exactly are we getting. Okay. Okay, here we are having 10 into 2 to the power x. Here also I want to keep it as it is without adding the powers. Okay, let's not add the power. Let's keep it as it is. 2 to the power 1 into 2 to the power x. 2 into 2 to the power x. Okay, this one also I want to write 2 into 2 to the power x, so that this 10 into 2 to the power x, 2 into 2 to the power x will be the like term. Right, Lena?
Yes,
I'm
ma'am.
talking about this term and this term. This two looks like term. So why to write the power together? When we are having like term, let's simplify it. So let's simplify. 2 to the power 2x minus 10 minus 2, that means minus 12 into 2 to the power x. 25 plus 7, 32 is equals to 0. Got it? Is
Yes,
it
ma'am.
clear so far? So does it looks like 2 to the power x whole square minus 12 into 2 to the power x plus 32 is equals to 0. And if we will be taking 2 to the power x as a t, so we can write it as a t square minus 12t plus 32 is equals to 0, which is a quadratic equation, right?
Yes, ma'am.
8 4 times 32, 8 4 12. So we will be having t square minus 8t minus 4t plus 32. Let's do it quickly. T minus 8 and minus 4 we will be taking. So t minus 4. So t value what we got? We got t value as a 8 and 4. Is it clear?
Yes, ma'am.
T means what? 2 to the power x is 8 and 2 to the power x is 4. So x value we can find. Exponents and powers chapter you have done. Right, Lina? What will be the value of x
Yes,
from
ma'am.
the first case? And what will be the value of x from the second case? Please tell me quickly. X is
3,
perfect. Next one, x is
2.
perfect. What we needed to find here, x value. We have already found x value. But whenever we are solving logarithmic a question based on logarithm, we have to check whether the x value, whatever we have found, is valid or not. So our first term is log 2 base 3. Here x is not there, we can't substitute. The next term is log 2 to the power x. Our x is, one of the x is 3, another is 2. So if we will be taking x value as a 3, it will be 8. 8 minus 5 will generate a positive number, that is fine. If we will be taking x value as a 2, the other value of x, it will be 4 minus 5. Okay, it will give us log base 3. 4 minus 5, this will generate a negative number. Can you see?
Yes, ma'am.
Log of negative is undefined. So x value as a 2 can't be taken over here. So there is only one answer, that is x value is 3. You can also check for the next one, same thing you will be getting. Got it? Got it, Lina?
Yes, ma'am.
So we will be writing not acceptable since it is making our logarithmic function undefined. And this is our answer. So what is the x value? X value is only 3. Clear? How we did so? We have used the concept of the AP, that is 2b is equals to a plus c. Okay, let's do few more properties are there quickly. Considering numbers in AP, whenever we have to consider three numbers in AP, uh, let's take A, B, C are in AP. So rather than taking A, B, C, we will be taking A minus D, A, A plus D. This is how we will be taking. If we have to assume anywhere that let's say three numbers x1, x2, x3 are in AP. So rather than taking x1, x2, x3, please take like this. Your simplification, calculation, everything will get simpler. Okay. So this is also one of the property number 3. Or if you have to take four terms, then we will be taking A minus 3D, then A minus D, then A plus D, then A plus 3D. This is how when we have to choose, let's take four such numbers which are in AP. So we will be taking like this. Okay, here you can check the common difference. We have kept it properly and it's same for all the terms. Okay. So if you have to take three terms, let's consider three terms are in AP. So we will be considering A minus D, A plus D. And if we have to take four terms in AP, we will be taking it the other one, A minus 3D, A minus D, then A plus D, A plus 3D. Okay. Let's move ahead. You can note it down. The next property is the sum of terms of an AP equidistant from the beginning and the end is constant and is equals to the sum of first and last term. Let's understand what exactly it's saying. So it says that the sum of term of an AP equidistant from the beginning and the end is constant. And that is equals to the sum of first and last term. So let's say we are having an AP where the first term is A, second is A plus D, third is A plus 2D, fourth is A plus 3D, fifth is A plus 5, fifth is fourth, first, second, third, fourth, fifth, yeah. Fifth is A plus 4D and sixth is A plus 5D. Now what exactly this property says, that the sum of term of an AP equidistant from the beginning and the end. So let's say we are taking this one and this one. Can you see both are equidistant from the beginning and the end? This one is like we have left 2 and then we have picked one, this one. And then here also we have left, just kept it aside 2 and we have taken one of the term. Equidistant term we have taken from the beginning and the end. Are you getting it?
Yes, ma'am.
Here it says the sum which is equidistant from beginning and end. Let's find the sum. A plus 2D plus A plus 3D That is 2a plus 5d. This is the sum, right, Lena?
Yes, ma'am.
Then it says is equal to the sum of first and last term. Is it equal to the sum of first and last term? Let's check it. Is it equal to the sum of this one and this one? Is it so?
Yes, ma'am.
So, yes, that's true. And that will always be true. So just keep this property in mind that that if you are taking two terms which are equidistant from the first and the last, so that sum will be equals to the sum of first and last term. Okay, now let's move to the next property. These properties you are not going to use while solving questions from NCRT. In NCRT, you are having questions related to AP are very simple. Like if AN is equals to 2n plus 5, then find the first term, then find the second term, then find the third term. These type of questions are there from AP. Okay. These are the properties which will help you when you will be solving question from JEE. Okay. So just note it down and keep it aside. We will be taking the questions from NCRT also, and along with that, we are taking questions which are related to this concepts also. So the next property says every term of an AP is average of the term equidistant from it. So again, let's take the same general form a plus d, a plus 2d, a plus 3d, a plus 4d, and a plus 5d. What exactly the statement says? Every term of an AP is the average of the term equidistant from it. So if we are taking this term, every term means let's pick any term from this AP. We have picked one of the term from this AP. Okay. Is what is average of the term equidistant from it. Okay, is it average if we are taking one term here and one term here? So is it average of that? A plus 2d plus a plus 4d by 2. This is how we find the average, right, Lina?
Yes, ma'am.
Let's see whether it is average or not. So 2a plus 6d by 2, a plus 3d, right?
Yes, ma'am.
So yes, every term of an AP is the average of the term equidistant from it. Okay. Now the last property says, the last property is if each term of an AP increased, we will be solving one question related to it to understand it, or decreased, multiplied, or divided by same non-zero numbers, then the resulting sequence is also in AP. So if suppose I am saying 2, 4, 6, 8, these are in AP. Now if you will multiply same number with all of them, still that will be in AP. If you will divide all the number by same, number, still that will be in AP. If you will add something to all the terms, still that will be in AP. And if you will subtract something from all the terms, still that will be in AP only. Are you getting it? Are you getting, Lina, the meaning of this property?
Yes.
So let's
Yes,
solve
ma'am.
one question related to that. So the question is, if B plus C minus A by A, C plus A minus B by B, A plus B minus C by C are in AP, then show that 1 by A, 1 by B, 1 by C are in AP. How to do so? Let's see. So if we will be adding 2 over here, we'll be adding 2 over here, we'll be adding 2 over here, still that will be in AP, right? So let's add 2.
Yes.
Can you tell me what will be the first term after doing the simplification? Please add 2 quickly and tell me what will be the first term, Lena? 2A minus A. Will it be A plus B plus C by A? Will it be again A plus B plus C by B? Is it so?
Yes, ma'am.
Now let's divide each and every term by A plus B plus C, because we are allowed. This is also in AP, because we have added same number with each and every term. Now we are going to divide by same term with each and every, like we are going to divide the same term in this AP, like each term we are going to divide by A plus B plus C. So if we will be dividing each term by A plus B plus C, here we are having A plus B plus C by A. So this cancel out each other. Similarly, the other one, A plus B plus C, will also get cancelled. So are we going to get 1 by A, 1 by B and 1 by C still in AP?
Yes, ma'am.
So we are free to go ahead and to do the multiplication, division, addition, subtraction. But the only condition is we must do the same thing, same operation with the same number we must apply with each and every term. Then only it will remain in AP. Okay? Okay, Lina?
Yes, ma'am.
So these are the complete discussion about arithmetic progression. I wanted to start geometric progression. Let's just see few questions, just the formula related to geometric progression. So just like arithmetic progression, there is a geometric progression. Okay, what is geometric progression? Here, the way we were having in arithmetic progression, the common difference. Here we will be having the common ratio. So the sequence can be like 1, 3, 9, 27, 81. So if you will see this sequence carefully, you can see 1 into 3 is 3, 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. So rather than adding something to each and every term, here something is get multiplied. There we were having common difference because we were finding the difference of the second term and first term. Here we will be having common ratio. Common ratio we represent by R. Okay, the way we were representing over there with D, common difference, here we will be representing by R, and that is the second term divided by the first. Similarly, we can also find common ratio R by 9 by 3. Okay, we can also find common ratio by taking 27 by 9. So you can see we can take any two consecutive term and we can find the common ratio. Okay, the second term divided by the first term. The general form of AP looked like A plus D, A plus 2D. This was the general form of AP. But the general form of GP is A multiplied with the common ratio. Then AR multiplied with the common ratio again. Okay. Then this total AR into R multiply with the common ratio again. So that's why we say in geometric progression, our sequence looks like AR, AR square, AR cube, AR to the power 3. What will be the nth term? So here we can say the first term is AR to the power 0. Second term is AR1. Third term is AR2. The power is 2. Fourth term is AR to the power 3. Fifth term is AR to the power 4. So nth term will be AR to the power n minus 1. Right, Lena?
Yes.
So nth term for geometric progression formula is AR to the power n minus 1. Okay? We will be just proceeding with